Hey guys! This video is the first of the Playing with Arches series. We're going to look at some cool mathematical tricks which can help you with procedural placement, and let's jump into Photoshop right now and have a look at our input variables. I made a quick drawing of some arches so we can understand which variables we are going to be iterating with. Now, to start with, we have the width value, and this one is different per segment. That's the most important to know from it. It also links to another value, and that is the height of the arches, because those are circular and they must be linked to the width segment. Now we could look at the total height of the arches. That one also is linked to another one. So if you look at the sine one, you can see this second value, that is the height from the top to the start of the arches. That's never going to be larger than our total height, so we can make a nice link between those two. Now then we have some smaller variables like the radius of the pillars, like the height of the pedestal, and like this little top area over there. And those are about the values we are going to be needing. Let's start by placing a geonode, as always. Place down a curve. This curve is going to be our main arches curve. So let's get into the top view and let's draw a nice curve. I'm going to have a few segments like this, and that should be fine for now. Alright, let's go to a perspective viewport again, and that's our starting position. Place down a subnet, and this is going to be our tool. In here, place a convert line. So when we have a look at our little geometry over here, we now have separate primitives, separate segments, which can contain their own values. Now also place down a facet and set it to unique points. So we are certain each of our segments has its own points which is needed. Then place down a prim VOP. In here we are going to set a prim position attribute. So place a bind export. Set it to prim position. Set it to be a vector. And we want to wire in the position in there. Alright, if we now have a look at our geometry spreadsheet, you can see that our primitive has a nice position attribute, which is the middle of the primitive. Now place down a point VOP, and with this point VOP we're basically going to be scaling our segments inwards. Also place down a null. This is going to be our control node, so let's just call it control. Let's adjust the color and the shape a bit so we are certain, and we always know this is our control node. And for now let's add our the radius of the pillars. So let's just call that radius. Alright, and set it at 0.1. That's fine for now. Let's copy this parameter. Inside of here I want to place a null. I'm gonna be calling this radius. I will promote this, and now I can paste relative reference in here, and I have my radius value. So that's nice and set up. Let's get our prim position. So get attribute. Let's wire in the prim num in there. Make sure it's set to primitive. First input, it's a vector, and the attribute was called prim position. There we go. Now, place down a negate node. We're going to be negating the position of our initial point, and we are doing this because we can now get. We want to inset the inner points of the segment because it needs to be inset towards the radius of the pillar. Now, we need to add these two values together, the prim position and the negated position value. Normalize this. And multiply it with the radius. And wire in the radius. Alright. Now add this with the initial position of the point. Now when we add those together, you can see we have our segments with an inset. Alright, so if we would change the radius right now, yeah, you can see it follows. It's a very small size we're working with at the moment, but we can scale it up later. Alright, place down a primitive VOP again, and also place down a measure node. The measure node needs to be done first, and with this measure it is set a parameter, and that's perfect. Alright, let's wire that in. Place down an inline node, an inline code node, wire in the prim num, and wire in op input 1. Okay, the output type we want to have is a integer array. Let's call this prim points. Prim points. All right. Then I also want this name to be geo because I like that. And now here we can write down $prim points. That's the attribute we are going to set. Equals prim points the expression. $geo. That's our first input. And then $prim num. All right. And that should give us an integer array with the points belonging to the primitive. Now, get array elements, because we know we always have 2, because each segment has only 2 points. We can get those 2 points by getting the first index and the second index. All right. From this, we need to get the position. So get attributes, wire it in, and we need to get that from the first input. It needs to be point, and we want to get the position. So let's do this for both of them. And now we also need to get the parameter. So let's type it in. I want this to be a vector. I want this to be the middle value of a vector. So, take the other one, float the vector. Let's write it into the middle. And because I want to add the parameter to the height of this thing, I'm going to make a very, very rough arch at the moment. So let's place an add node. And let's add those two together and do the same for the second value. All right, now place an add point. And let's place another add point. If we look at the points, this looks about right. So our segment has placed another point above each initial point, depending on the parameter. And that's exactly what we want, because we need that height of the arch to be dependent on the width of our segment. All right, now to connect these as a nice primitive, we first need to remove the initial primitive. So let's place down and remove primitive. And wire it in. Then let's place some add vertex nodes. We're going to be needing 4 of them. All right, and add primitive. This one needs to be wired in everywhere. And we want to connect it like this. So start at the bottom, go to the top, and then go to the bottom again. So we need to start with our initial point, which was this one. Then we go to the second one, the third, and finally, oh, that's not right. There we go. All right, so this is the rough, very rough shape of our arch. Now, something is not completely right, because we only need the half of arch. So we can multiply constants. We can place this node over here, multiplied by 0.5, and there we go. That looks a lot better. All right, place down a polybevel and make sure it is set to points. Now, if we play with this, you can see we get some kind of arches, but of course we want to link this to our initial value, our initial width value. And we can do that. That's actually doable. Let's get an attribute promote. And let's place this after our measure node. So let's place it over there. And at this moment we have our parameter and we don't want to delete it. We want to change its new name and we're going to set it from primitive to point. And we're going to be calling it p-scale. Now, after we do our little magic, because over here they're still flat, then we are making our rough arches. Then the corner points over there, they don't have the right attribute yet, they don't have the right p-scale yet. So I'm going to place 2 attribute modes and they're going to be for p-scale. And it's going from point to primitive. And I want to take the maximum value. And then I do it the same thing vice versa, so from primitive to point. So we are sure we have nice p-scale attributes, which are the same for the entire primitive. Alright, and the p-scale attribute is also the one we can use for our fixed distance. So if the fixed distance is 1, then we can use this value. Okay, so if we would set this to 0.5, it would be around perfect. Because of course our perimeter is this entire length and we only need 50% of that. So we can set this fixed distance to 50%. Now, next thing we want to do is go into our control node and we also want to place our height attribute. So this is also a variable you will be able to change. And this height attribute is, we need 2 because we have 2 different ones. We have one that's depending on the arch and we have one that's the entire length. So the second one I'm going to be calling relative height for the label. Alright. And I'm just going to make a very quick visualizer for this. So I'm going to place down 2 tubes. And I want to make sure that each of these tubes has a very small radius. And I want it to have its height needs to be the same as our the height of our pillar, the entire arch. So let's copy this into there. And I want to make sure that it's standing on top of the ground. So not like this. Radius can be a little bit thicker. Let's copy the height into the center and multiply it by 0.5. Alright, that's looking good. And the next visualizer, we're gonna use it a little bit later. So make sure this is set to, it's a little wireframe. And then we can look at our body bevel. Alright, so that height is way too large right now. We can play with this later. Of course, all the scaling right now is really messed up. But right now you can see this is how high the entire thing is supposed to be. And we can play with it, and that's nice. Now, we want this arch to be at a certain height depending on our relative height. So our relative height is going to be a value between 0 and 1 because we're going to link it directly towards the height. So I want you to place down a transform, and inside of this transform let's take the height, copy perimeter, paste in the y direction, and also get the relative height. And let's copy paste in here also and multiply those two with each other. Alright, that's a start. So right now we are taking this entire value, so it needs to be less than this for sure. Let's set it around here. Alright, now if you want to make sure that your this arch never goes over the total value, then we can do that. That's actually pretty doable, because that means that this length value you can see over here is the highest it can go. It's the highest our bevel should be able to go. It's also the highest our perimeter is allowed to be. So well, let's do it. We're gonna insert some clamping over here. So after you've measured it, let's place down a primitive VOP. And oh, that's not the right node. There we go. And let's place it down and let's dive in. For this, we need to have a few variables. We're going to need the height, we're going to need the relative height, and of course we're going to need the perimeter. Now, let's call this one height. Let's copy it, and we need the relative height. All right, and with a bind node, we're going to need perimeter. There we go. Those are our 3 values. Now, let's promote perimeter for these two. And let's get those from our control nodes. So we have the height, which is going inside of the first value. And we have our relative height, which is going to go into the second. Just quickly rename this to clamping. All right. There we go. Now, first we need to multiply these two together. Then let's negate them, because we don't need the bottom height, we need the top height. So let's negate it and add it together with our initial height. Oh. There we go. No, we need to play down a multiply constant over here, because we are in a different node, we are multiplying it by a half, and right now we don't need it to beat it yet. So just to make sure that we solve that little thing over there, we have this. All right, place down a clamp, and we only need to clamp the maximum value. We're going to be clamping our perimeter, and find export. We're going to export the perimeter again. So now this is an adjusted perimeter value. There we go. And now you can see it never goes over our total height anymore. Oh, that's nice. But we also want to have a little top value, a little top increment at the top. And that's where the second tube is going to be coming in handy. So I'm going to merge these two tubes. I want to be sure that the second tube starts at the top, because it's going to show the top value. So let's give it some values. It starts at the total height, and then depending on its own height, we're going to offset this a little bit. So minus relative times 0.5. All right, and let's set it way smaller. There we go. Yes. And this also needs its own variable. So let's create that one right now. I'm going to be calling it top, or top height. Top height would be nice. All right. There we go. And this should also be a very small value. And let's throw it in here. There we go. So we also want to subtract this from our how high our arches can go. So right now they go to the top, but if we look at this in ghost form, we want them never to be able to go higher than this. So let's add it in here. Make sure you have the top height copied. And let's go into our clamping. We're going to be adding one more value. So place another null node. Let's promote this. This is going to be our top height. And now I want to negate it, because we need to subtract this value from our clamp value. And then place an add node. Add those two together. And make sure the value is there. All right. And as you can see right now, it is again, we have the small problem with it's twice as large at the moment, or twice as small. So make sure this multiply constant is after the add node, because you need to do it last. There we go. And now they can never go above our top height. Pretty good now. So let's change a little bit with we'll just mess around a little bit with these values. so it looks a little bit better. Alright, for now I would call it fine. Also, let's make sure our poly bevel has a little bit of a higher division count, so it looks a bit nicer. Let's place all of this stuff after the radius, after we set the radius value. So that's over here. Let's set this set radius, and after that one we're going to put everything into a subnet. I like to color my subnets green and make sure my input is blue, and I place an output node which is purple. That's usually what I do, just so I'm always aware what is what. And let's call this arches. Alright. Let's check that when we put it into a subnet, all values stay linked correctly, which it didn't. Oh, excuse me. And there we go, that looks better. Let's go out of the subnet. And it's named arches, so that's nice. And now I want to make a few very basic pillars. Later we're gonna change these ones a little bit, but to show you a cool trick. So if we take the copy to points, and you can see over here our initial points. We don't want to do the facet yet, because then we will be doubling our point amount. And I want to have a point triangle. And with the point triangle, I'm going to be setting the scale values. So at scale dot x is going to be a channel, and the channel I'm going to refer right now to the radius, and it doesn't exist yet, but we can press this cool button over here, so create spare parameters, and now we have a nice slider. So that's cool. Copy this one, and let's do the same thing for z, because x and z are going to be the same at this moment. The only one which is going to be different, and it's going to need its own separate channel, is going to be the y value. This is going to be the height of our entire arch. Okay, and let's press the button again, and we have our height, and now we can get those values from our control node. So the total height, let's copy it over. That's going to be in our I channel. And the radius we also have over here. And let's place that over here. And now we have some nice scale values for our points. And we will be placing down a tube right now. And let's set it to polygon. Wire it in there. And also make sure it is set on the ground plane. There we go. Now we have pillars with the exact right height. And we see we have our arches. A quick poly wire for now. Wire it in there. Oh, that doesn't look good. Wire radius smaller. A few more divisions for now. That's fine. Yeah, alright. That looks funky, but this is not the final form. Just a quick overview of what we've been making for so far. If we would now be playing with our curve, you can see it's very adaptable, and you can change the height of the arches. They will grow with you, and this allows for a lot of flexibility. Thank you for watching part 1 of this series. I hope you've enjoyed it, and in the next series, part 2, we will be talking about some of the traps you might fall into when dealing with this kind of placement, how to optimize it for your user, your game designer, or whoever is going to be using the tool, and just overall more cool tricks with arches. So I hope you had a good one. For now, this was Dokai. Bye bye.